All right, here we are, top of the hour, June, the end of June, six months into the year. I don't know how we managed to get through half the year so quickly. This week, I always say this almost every week. This week was crazy, but this week was incredibly crazy. We had a variety of events. We had the Toronto meetup where we had 100 people and I think, what was it, 450 people registered for it. We had Paris on Monday, which went really well. There's so much happening. I don't even know where to start, but I'm going to start with Rob. How's it going, Rob?
Good, good, good. Yeah, it was a really busy week, and lots of folks are excited about holding events all over the place. Berlin, Stockholm, next one's up, and um, Indianapolis, uh, boy, um,
Yeah.
Belgium. They're all over the place. So it's wonderful. And yeah, I'm looking forward to seeing this trading platform today. That's going to be interesting. The ability to build out complex systems more and more becomes available to more people more quickly. So that's what it's all about. We have a great lineup today this week, too, Roof and folks. We've got Chris Poulter, part of the
All
UK
right.
group, and Chris is he's a serial entrepreneur, and he's working on the platforms to orchestrate and optimize the agentic coding flow. So right on target. And then Everett Clavin is back. He's the founder of Evangelist Technologies. I think he qualifies as a rocket scientist. He's got his master's in aeronautical engineering or aerospace engineering, and again working on multi-agent orchestration, right, which is what it's all about. And then we're happy to welcome the celebrated Alistair Kroll. So Alistair is he's from product management and telecom. He built and sold uh, Co-Radiant to BMC, and he launched Year One Labs. That's an incubator. Chaired O'Reilly's Strata and UBM's Cloud Connect. He founded the FWD 50, and he's taught at Stanford, at Harvard. He's co-written 3 books, including Lean Analytics, which is pretty much required reading for startups these days. So
Yeah, it's a
happy to
it's
have
the
Alistair.
it's the Bible, and his latest book, which is a really good one, is Just Evil Enough, which I just kind of love that name because it kind of summarizes kind of everyone's methodology these days. So let's not let's get to it. There's a lot to cover.
Totally.
Again, thanks Rob and Brad and the whole team in Toronto for putting together an amazing event on Tuesday, and the Tribal Scale team for sponsoring it, as well as Vincent and the crew in Paris. I wish I was there with you guys, but I could see the Eiffel Tower in the background. Very jealous, but I don't have time to travel these days. I'm way too busy for that sort of thing. All right, so let's get into it. I think a lot of people today are really excited about this idea of an MCP or Claude Code generated and managed trading system. But before I go there, I got to give you a kind of step by step to where and how I got to where we are today since Monday, which is this is a lot to cover. So I'm gonna go fast. You might have to watch this and in slow motion later. But so I started the week. I've been on a Rust kick. The Rust has been particularly good. And so what I started this week was creating a platform that essentially allows me to create a kind of quantum proof series of tools that allow me to manage agents in a kind of decentralized fashion. So I created an SDK, and it's super fast, super secure. It allows for, in the most simple terms, it's a dark net for agents. I know it sounds scary, it probably is. Basically, it's hyper fast and hyper secure communication channel. It handles things like the use of passwords and secrets and communications. It has a built-in economy system. So as agents collaborate, they can generate value and share those in the form of resource utility vouchers. Yes, RUVs. They're called RUVs, whatever. And then I included anonymous onion routing components, quantum resistant dark domain system. So you can use it to create sort of whatever.dark.com. And I like dark because it doesn't exist as a domain. So you can create your own secondary darknet. You can change the dark with whatever you really want it to be. And you can plug that in also to DNS services like Cloudflare and others if you want it to sort of sit between the dark world and the real world. It's all managed through an MCP. Everything I'm about to show you is kind of a cascading sort of series of components that connect to each other through MCP. So this facilitates the next, and the next thing was sort of interacts with the previous thing. So they're all kind of building on each other like one of those Russian dolls where you're kind of peeling each layer off, and then the next layer, and inside this and that. So it's really interesting. So you can see I've got passwords. I'm not going to go in the demo of this because we just don't have enough time to show you everything I've built. So you can see here I get my resource and so on. But this led to another component. So then I needed a practical application of the SDK. So I created what I called a decentralized autonomous agent structure to essentially build businesses on top of the previous platform that could operate autonomously using agents as a kind of core worker in the infrastructure that provides things like an AI-powered decision making, economic self-sustainability. So these systems can not only build and interact and adapt, but they can make their own value, whether that's real money or crypto or their own invented currencies, whatever. They have autonomous governance. There's also the ability for it to be sort of self-determining. I can put in guidelines. It's quantum safe. It's kind of the implementation of the previous, also has an MCP on top of it. So if you want to create your own autonomous agents that live in sort of the world of the kind of, I don't know what you want to call it, kind of latent space darknet, if you will, you can do that. It has the ability to be, again, completely autonomous loops. It even has the ability to share computational resources. So these systems can actually create their own that then shares the capacity of GPUs and CPUs, networks with each other or other people, all on the fly, which again is just mind blowing. So between these two projects, we're looking at about 100 hours of continuous swarm development across 30 swarm agents. So we're sitting around 3,500 hours of continuous development and roughly 2 to 3 million lines of code. 2 or 3 million lines of code, and this is just since freaking Monday. Anyway, you can look at that DAA. So that led to the next thing. I'm like, okay, so this is all built in Rust. So then I came up, well, this is interesting. Why don't, and this is something we did yesterday. Well, I'm looking at sort of porting some of these Python tools that are optimized for creating neural networks. And one of the more popular ones is something called FAST. So the FAST is the Fast Artificial Neural Network, which is built in C. It's one of the most popular C-based neural networks. It's complicated, it doesn't have really good memory management. It's verbose and slow. So on yesterday's live coding session, I'm like, why don't we see if we can implement this in 90 minutes in Rust, which we managed to do, fully functional. Again, a couple 100,000 lines of code. And then it created something called neurodivergent, which I love. I kind of love that name because I think I might be neurodivergent. But anyway, what this does is allows you to create hyper fast and hyper targeted neural networks that you can embed in just about anything. And they're super small, super fast. You can see I've got different types of uh, models I can implement and neural forecasting capabilities. And well, here's the stats that are crazy. If you look at traditional Python implementation of neural forecast, we're looking at a 200 to 400% improvement in terms of speed. And this is just me quickly doing it on some crappy GPUs that I got up. What was it? Fly.io. My inference speed increased 500% on the crappiest GPUs. Memory went down 75%, which is just crazy. But look at this, the binary size dropped from 500 megabytes down to 5. So I can embed this in browsers, I can put this on IoT, I can embed this in like, just random objects. Cold start times went from 10 seconds to 50 milliseconds. Just mind-boggling. And I built this in freaking 90 minutes. So all these tools are leading towards the thing you're probably most excited by is this idea of where did I put it? Here it is, a trading system. So I'm like, oh, I've got all these tools. This is built in Python, by the way, because I built it quick. But this is essentially playing on top of what I built previously in the Claude Flow system. So I'm using swarms as a combination of all the neural components you saw before, built in those various components, and then I implemented it. I get basically an interface in Python. I might do a Rust if I get time. But basically, what this does is creates an MCP powered trading system, which I ran most of the week against. I had a previous one, and the results are at some of the stats you can see here. I'm using momentum trading. I'm using mean revision, swing trading, and mirror trading. Mirror trading is interesting. Basically, I just pointed at the U.S. senators and Congress people and said, buy whatever they're buying. But the crazy part of this is the time it takes me to do it. I was looking at a kind of I'm going to make this up, temporal intelligence. So when you look at traditional investment platforms, a lot of it's based on latency. How fast can I trade based on predetermined sort of procedural components? Like I'm doing these certain types of investments and I just need to do it faster than the next guy. But what it's not doing is adapting to whatever it needs to do based on the information that's coming to it. So it could be like a random tweet from a leader of a country or a senator or some other information, and I need to make that I need to make the determination and understand the ramifications of that as fast as I possibly can, rather than just basing on the speed of light and latency. So I ran this again, the cheapest GPU cluster I could possibly find, and ran it for several days, and the results were astronomical. I saw a 65x, not percent, but x speed up in terms of capability. I've increased this to 21 tools now, but the stats that you're mind blowing. So when you look at my traditional environment, I'm seeing now a 1.8 millisecond response time for complex types of decisions. So that those are like taking in A, B, and C and deciding whether that's a good sort of decision to be made. Rather than taking sometimes 2 minutes, I can do the same result in 1.8 milliseconds. We're almost at the point of doing nanoseconds in terms of that. And this is on a A100 with 80 gigs of RAM. This cheap hardware. I can't even imagine what an H100 would look like. Batch processing is interesting too. So batch processing is the concept of taking multiple assets, stocks, bonds, whatever, and then making sort of a graph structure to determine how that all interconnects to each other. I can look at 128 different assets and I can get a response time in 24 milliseconds, which is again just bonkers in terms of capability. In terms of high frequency trading, I'm seeing similar things. I can traditional research, which would take 5 minutes, I can do in 47 milliseconds, which is crazy. So I'm not going to spend too much more time on this. I'm going to jump in and actually show you what this actually looks like, which is probably the more exciting part of this whole thing. All right. So I haven't published this, guys, because I'm worried about getting in trouble with regulators, and maybe someone smarter than me can tell me if I'm even should be worried about that. But let's just go back here. So there's a couple components that exist. So it's an MCP. So for the most simple part of the MCP, we can go here and we'll go and look at RU because it's got a nice sort of interface. So we can see here that here are all my endpoints, but this isn't actually how I'm using it. I've actually integrated it with my Claude Flow swarm. But just to visualize it, you can see here I've got ping. This basically tells me if it's working. I have the ability to list different strategies, get strategies, do a quick analysis. You can see the symbol that I'm looking at, whether or not I want to use a GPU. Sometimes I don't use GPUs because I'm cheap. Simulated trades, so I can do a whole simulated series of trades. I can do 1 billion simulated trades in roughly 100 I think it was 100. I don't know the exact number. I'm not going to say how long it was, but it wasn't very long. Get portfolio status, like how's my portfolio actually doing? I can do real-time news analysis. I can plug in Bloomberg. I can plug in available. I can use Firecrawl, whatever I need to get. I can get sentiment analysis in real time. Is this good? Is this bad? So all the different parts of the swarm are looking at all these different parts of the equation. So if I have a 50 agent swarm, one agent might be geared towards back testing. The other agent might be looking at the optimization strategy. Another might be looking at risk analysis. And this is all happening concurrently with them all kind of collaborating to figure out what and how it should work. Then I can, using Claude Code, I can plug this directly into any existing trading, whether it's stock trading, bond trading, crypto, doesn't matter. And it'll actually facilitate that. So all you need to do is point Claude Code at it and say, implement this against ABC API for trading, and it's done. You'll just build it on the fly. Here's the performance report, similar to what I was showing a minute ago. Correlation analysis. Here's my benchmarking. I built a completely separate benchmarking tool just to prove that I wasn't hallucinating this whole thing and this was actually working. Then I've got a neural forecasting system. So back to the other system, I said I can create custom neural networks that are built explicitly for a certain kind of trade, and then they learn and adapt and get better as you use it more. Then you can train those on the information. So as it's trading, the system gets better. It's self-optimizing and deterministic. Then it can do a self-evaluation, neural back testing as well. It's crazy. Like, and I built all this stuff this week. So taking it further, because I don't have a lot of time, and this demo would literally be several hours if I showed you everything. But the first part I built here was something called Claude Flow Neural. Now we'll do help on that. So Claude Flow Neural essentially is allowing you to essentially execute similar to the original Claude Flow, but specifically optimized for trading these stocks. So we can go to Claude. Let's go to Claude MD and see if we can see some details. So this is the core guidance system. All right, let's go here. So we can see that I've defined sort of the MCP, which I'll show you in a moment. And these are the different guidance tools, different availabilities, lots and lots of stuff. So this is basically guiding it in this, and then we have MCP tools directory here that tells it how to operate, and here at the neural trader components as well. So a lot of stuff, right? You can see that the parameters and strategy. There's a lot of code underpinning this. So let's go back here, and I'm just gonna straight up run it. Right. So we've got different neural forecasting options here. What do I have? Did I include an example? Yeah, here it is. Yeah, let's just run this one for Claude Flow Neural. Oh, I see an error I need to fix. I haven't published this publicly, so it's not that big a deal. For Neuro, we're gonna do forecast Apple Horizon 24. I'm not gonna use the GPU on this because I'm on a code space. Oops. What did I do wrong? No such command. Let's go into the actual tool. I'm not going to worry about that at the moment. So we're going to go, I'm just going to run Claude code dangerously skip permissions. And I'll show you how this looks. So let's make this bigger so you guys can see it. We'll go here. So I've got all these commands, right? So you can see here that I've got all the commands for running it. So we can have the memory system, the neural forecasting, system orchestration, trading strategies, correlation analysis. So these are all now different commands. So get news, sentiment, whatever it is. So it integrates directly with Claude Flow as the orchestrator. So you can see here I get MCP direct usage, direct tool, and using Project NeuroTrader. Let's just do that and see what happens. And now I'm doing it singularly, but I can do this again as a swarm. So at this point, it should execute. It's going to do a little bit of thinking. So now, yeah, let's analyze the Apple and I don't know, Microsoft stock using the MCP. Now, again, all this can be automated because I've got command line tools, right? So this can just run autonomously. I'm doing it manually just to sort of show what's happening. So now it's spinning up a cluster. Each of those is running as an autonomous swarm. So these are all happening now it's looking at the different horizons. It's trying to figure out what the confidence level is. And now it's going to quickly do an analysis. And it's going to look at the neural forecasting. This is all autonomous. Literally, once I point it at it and say go do it, it'll go figure it all out for me. And I can then say based on this, it'll give me a synopsis, like the current and predicted values. I think in this case I might be using static data on this because this is my training environment.
Where's the
But
price data coming from?
Static data that I imported to do the training. But I can import Bloomberg, whatever. It's live. I can use the web search capabilities. For example, I could say use the web search to get late. And this is the cheapest way to do it. It's gonna be the slowest, but latest data and do a deep analysis. So basically all you're doing is pointing this thing at the problem or whatever it is you want to do or trade, and it goes and figures it all out for you. That's it. It creates the swarm, it does the analysis, it does the search, it does the trade. It can do this, it can do the trades in 1.8 milliseconds. So just to put that in context for a moment, when you blink, that's 100 milliseconds for a blink. I can do that in 1/50th, I guess, of the time it takes you to blink. I can make the decision across multiple vectors and then make the trade repeatedly forever and let this thing run, and which I did for a week. It's just crazy, and you got all these different options. Here you can see the MCP. Let me run this. Let me let that continue over here, because the web search is actually the slowest way to do it. But I'm going to go here and I'm just going to run Claude again. And this time I'm just going to show you what the MCP integration looks like. So you see here MCP. Yeah, oh, no, I did the wrong one. And I think I might have to change the naming convention. There, let's try that MCP. Yeah, I think I might have named my MCP commands too closely. But let's go back. Basically you've got Claude, and maybe I'll write a script or something, but MCP. Basically you can add MCPs to Claude, and you can see here that I've added that MCP. So it's basically I've created a wrapper for it. I didn't bother creating a remote MCP for it because I didn't really need that, but I guess I could, I suppose. But basically it'll run against all these different vectors. You can see automation examples, tool combinations, and you're just invoking these options. Correlation analysis, whatever it is you want to do, and you could say do it all. Give me the world's best trading algorithm and go figure it out. And I'm gonna go to bed, and tomorrow morning it would have done it. So now you see it thinking through the process. I've completed searches for both stocks. It's doing analysis, and then it'll dream up the optimal arbitrage in this scenario for maybe trading Apple against Microsoft or something. Whatever it is I want it to do, it'll literally go and figure it out in the most optimized way possible.
Options up next.
It does options, it does crypto, it does anything that I can get, anything that has a publicly available or privately available trading API. All
Yep.
you need to do is basically say, go use that API. So name what's that one that's popular for like day traders?
Robinhood, Tasty Trade.
Yeah, there's an API.
Sink or
what's it called?
swim.
Poly market?
Yeah.
The prediction
Gecko?
market?
CoinGecko?
Is
Oh,
it the
prediction
prediction
market.
market?
Yeah, what's
Thinking about Poly market. Poly market has they've got a GitHub
yeah.
repository from November with their own agents on it.
Okay, let's do this. Add Poly Market API to the trading system. Now I'm going to switch to a different plan here. I'm going to call this Poly Market, and this gives me a branch to the trading system. Create as a modular extension, and spawn a 5-agent swarm in parallel using batch tool. Continue TDD and continue until complete with 100% coverage. That's it. That's all you need to do to create anything you can possibly want to add to this. And now I'll just sit back, and it'll go and it'll add it'll research the Poly market system, figure out how the API works, and see now it's creating the to-do list. I just sit back and watch it do its thing, and then I'll have Poly market integration probably before this call is even done.
Ruth, I mean, this is obviously you are on the base Cloud Code interface, right? You're not really using Spark
No,
here
I
per
am.
se.
I am.
You are.
So so I've got to integrate it with right here. So you see these Claude commands, and I've got the source. So and there's a couple 100,000 lines of code that underpins the MCP. But you can see here, I got my GPU acceleration here. I got my memory systems, neural models, the different neural models I've created. But what makes it all work is this trading system. And there's a
Question
ton.
as well.
Yeah,
Can you hear me?
you can, yeah.
Yeah, I wanted to ask. So you mentioned earlier that you're currently running like some training test data. Are you running this in production with actual
Yeah,
real-time sources?
I'm not showing you guys that because I don't want to get on the SEC's radar if I can help it. So I'm just avoiding things that I think might get me in trouble. But
Okay.
you guys can tell the making,
I
the
mean,
difference
the
between what
reason
I'm
I
showing
asked
you.
that, the reason
Yeah.
I asked that specifically is because obviously these models have been trained on ungodly amounts of data, which
Oh, I'm
of
not
course
using
includes
I'm not
it
using the model.
includes
I'm not using those models. So this is not using LLM based inference for the data. I'm using custom neural network. So this is 100% a neural network based on the neural forecast system. So this is not a language model. The language model is doing like the swarm orchestration, but it's actually using this approach. So basically what I'm doing is I'm using it builds its own neural models specifically for what I need it to build for. So it's not biased
I see.
from whatever it was trained on. I'm
You're,
data.
you're kind of training your own like custom time series models locally and
Exactly.
then running
Yeah,
those in real time.
exactly. I'm using NBeats and I think the best model I found was this NTI, H model, which basically gives me time series neural network. And now I probably can't even describe it because it's probably beyond my comprehension to describe. So I'm just going to pop back in the Claude here and get it to describe it. I know we're almost out of time and I'm going like hyper speed here, but
It'll be neat to come back at the end and to see the integration.
yeah. So tell me about the model and how it works.
Are you setting limits? What are you using to set the limits?
I've got a guidance system there. It's part of the it's part of the MCP. So when we go back to the MCP, you'll see that I've got different options for that as well. Again, it's hard to show you everything because there's just so much going on here. But yeah, it does everything.
It's like
That's how.
I really believe it, and you're putting on full display, Ruth, that in the next 6 months, there just won't be a day trader on the planet that is manually looking at graphs and handles and waiting for the perfect moment for them to manually jump into a position.
Yeah.
That's
So
it's gone.
you're right. So this H hits is a natural hierarchical interpolation for time series. If you're going to do this, this is the model you want to use. I tried 27 different models. This is by far the best. And what this is a multi-stage signal processing, uses multiple stacks to process data at different frequencies through pooling layers with various kernel sizes. To be honest, this is beyond my comprehension. All I really know is all the things I tried or the swarm tried. This was by far the best one. Hierarchical stacks. We got interpolation mechanisms, and that I can explain it to me like I'm an idiot. I might want to say, but basically, it's creating its own model on the fly in literally milliseconds. Is all you really need to know.
Fantastic.
Hey, Drew,
Can we?
are you
Sorry.
using the news feeds to influence the models, or is it just purely on numerical data?
Yeah, no, I'm using news feeds. So I'm not showing that because I don't have rights to do that. But yeah, I'm using real-time news feeds. But
Newsfeed, sentiment analysis.
yeah, and so all of it. And then one of the swarms is doing simulation, and the simulation again is happening faster than you can blink, right? And so yeah, it's craziness. I don't know. I think everybody wants this. I'm just trying to figure out exactly how to make this available without getting in too much trouble. So I think I might need a lawyer or someone to tell me that I'm not going to go to jail for this. But yeah, this is it.
Just ask Claude Flow to draft yourself the appropriate liability release.
Yeah, he said that's
right.
doing my AI Hackerspace live from jail isn't really up on my list of things I want to be doing.
No, that's right.
You're right. So anyway, for those who are interested, I am giving access, if you can convince me on a case-by-case basis to my GitHub. You're gonna have to convince me that you're capable and worthy, if you will. But I've given a few people access, including some notable investors who have reached out. So we'll see. Maybe if I get the courage, maybe I'll release it next week. I don't know.
We'll do
Maybe
a ton of research first, right?
yeah.
Yeah. Very good.
That was a lot of information. I apologize. I went longer than I usually do today, but yeah, someone mentioned the Millennium Prize. I did the Reitman hypothesis there last year. I had no way to prove it.
I can just comment on the regulation part of it. If you charge money, you will be liable. If you don't charge money, it's kind of gray area from SEC perspective.
Still great.
Right. Yeah, great. Gray makes me feel great. Yes.
Yeah. Thank you, Ulas. Confirm the requirement for good.
Yeah. I'm not.
You can
I'm
charge
not
money. You just have to position it.
Yeah.
You'd have to position it correctly. If you say
So-
this is an idea generator, this is not a
Yes.
trade executor, then it's more. You've exited one legal domain and entered into another.
Yeah, I'm gonna call it SBF.
And then
What
what about
about-
the open source license and in general, the open source license?
I don't know, guys. I see Sam Bankman-Fried,
Open
and I'm
source.
thinking,
Yeah, open source license and let the users, install and run by their own it's not your concern, basically.
Licenses don't supersede the local governmental authority.
No, it
so
doesn't.
there's a
That's
law
the
that
problem.
invalidates
I
that
just want to
aspect
say,
of
I
the
think everybody
license.
here is assuming, I think everybody is here is
nope. Here's Alistair. You take it away, Alistair. You're up next anyway.
Yeah. Oh, we lost your sound, Alistair.
there are no norms. We don't live in a time of compliance. I don't think you can trust the SEC to do anything. The reality is that the reason that the stock market exists and derivatives exist, according to capitalism, has always been to find efficiencies and maximize the efficiency of capital as a way of directing our resources. If we now have a thing that can extract the efficiencies of the system, and there's no more profit to be made other than, essentially a machine allocating capital algorithms. If you get into the philosophy of capitalism, what you have is the sort of Adam Smith's perfect machine for market liquidity. And once enough of these machines get hooked up, there ceases to be any profit margin, because what you have essentially is this AI is using its information to do perfect capital allocation in the market. Like the whole reason that we allowed derivatives and future trading to exist was to figure out inefficiencies in the market. This company's not running as well as it could be. This capital is being invested somewhere it shouldn't be. This savings should be put into productive use. And in theory, there was a whole class of people called traders whose job it was to find those inefficiencies and tax them so they would go away. That's kind of how capitalism is supposed to work if you're a classical economist. We now have a system that Ruv is building, which looks like trading, but what it's actually doing under the covers is finding market inefficiencies and extracting revenue from them. And so if you want to get, like, I'm talking to a lot of companies these days that want to talk about how to make their employees do AI better. But if you want to take a step back, we no longer need the trading system to make capital allocation efficient, is what we're really talking about.
Yeah, well said. And what I'm doing is looking for inefficiencies. That's 100% what I'm doing. And I'm doing that using a GPU 1 billion times a second, which I built overnight while I slept.
Amazing.
So,
Alistair, we're in that segment, the guest segment. So, and you're one of our 3 Lightning Talk guests. So welcome, Alistair, and
hey,
the floor is yours.
Hey, hi, I'll keep it quick. Ruv, how long have I known you for?
We met Alistair back when I was trying to pitch the concepts of cloud computing. I met Stephen Pollack and said, you gotta meet Alistair. He's the guy. I think it was Stephen Pollack, and who's famous for being one of the first virtualization company founders. It was 2004, 2003. So
yeah,
20,
something like that.
More than 20 years ago.
Yeah, back when once upon a time the internet was as cool as AI is, and then cloud computing was as cool as AI is, and then big data was as cool as AI is. And I think we've been involved for at least a couple of those things. I also wrote a book called Lean Analytics that shows startup founders how to use data to make a better business faster. And I just wrote a book called Just Evil Enough about subversive go-to-market strategy that's pretty funny. So if you're interested in go-to-market, you can grab that. But what I wanted to talk about very briefly, I spent a lot of my time talking to all kinds of interesting people. I was in Dubai talking to the heads of policing from 60 countries a couple of weeks ago about how to maintain legitimacy in an era of technological asymmetry. So kind of ADHD as a career. The thing that I'm thinking about right now, Ruv, and I'll give you a very quick framing of it, and then maybe we can chat about it, is every major technology shift has a before and an after. And we allocated our capital, our energy, our resources, our staffing, and then some technology happened, and then we allocated again. So there's a misallocation beforehand, right? We had lamp-lighters, then we got electricity, the lamp-lighters went away. It is a career, and I'm not a billionaire, Chris, so I'm not sure about that one. We now have, with major technologies, have a misallocation problem. And I would argue in tech, there's been 4 big misallocations in recent years. The first one was the move from desktop software to software as a service, where a company was built to like send out disks and floppies once a year, and there were big updates. And now it's just you're using an app and it's software as a service, and the entire structure of your sales and your organization is different. There was the move from hardware to cloud computing. I founded a company that needed a lot of hardware back in 2001, and we were making appliances, but the economics changed a lot if you just use clouds. Why would you spend money on permanent hardware when you can pay for it as an operating expense? The next big one I'd say is social media, where companies were structured in order to deal with paid media instead of earned impressions. And so if you were a company that like set itself up to use paid media and traditional channels, you were obsolete when social media came along. And obsolete doesn't happen overnight. It takes a few years. But obviously we're in what I would call the 4th big miscapitalization of tech, which is that we are now allocating money to developers when we can't have agents. And that's a big problem that most people haven't realized. Most people are looking at the first order consequences, like how do I do my job better with AI? Some people are looking at the second order consequences. Do I need to hire another person, or can I use an AI? And what we really need to be doing is thinking of the third order consequences. Does this business continue to exist when something else can do this function? Like I just pointed out, if the goal of the financial industry is to, or the trading industry is to make capital liquid by identifying and removing inefficiencies, and there's a system that can do that better, maybe we don't need trading. Like that's a weird thing, speculative trading. That's a weird way to look at it. But I don't think we're thinking weird enough. So I want to share a couple of thoughts just off the cuff here. I spent a lot of time working with startups. I run a big conference called Startup Fest in Montreal. And we talk about unicorns in the startup world. The whole venture capital, commercial capital world is structured on this idea of 1 in 1,000 doing really well. And I think we're going to go from unicorns to millions of tiny horses. What I mean by that is, imagine you're making a scheduling and CRM software platform. You could make that very, very generic, and then it becomes complex to customize it to lots of things, like the Salesforce.com model. But in that category, there's a company called Tock, T-O-C-K, that's used for restaurants who want to charge people for the meal before they arrive. High-cost restaurants where people will book a reservation and then cancel. And so Tock is a sales CRM scheduling platform that's very, very specific to the needs of high-end restaurants. There's another one called Studio.Inc., I think, that's for tattoo parlors. And in many cases, the tattoo artist doesn't want you to know where they live until you've agreed to do the tattoo. So there's a whole negotiation on the artwork before you confirm the appointment. It'd be very hard to make one CRM that can be configured in all those ways, but you have like no CRM that's better than Studio for tattoo parlors, no CRM that's better than Tock for high-end restaurants. And so I think that's what I mean by millions of tiny horses. But the thing that I'm really interested in right now is I mentioned one of the miscapitalizations was the introduction of software as a service. And the SaaS world in many cases is referred to as shadow IT, because once upon a time, the CIO had software licenses. They'd stick a disk in a computer once a year. That was your new software. And then all of a sudden, some sales guy put in his credit card, and now you were using Salesforce. This was horrible for enterprise IT. It bypassed their immune system. They lost control. I talked to CFOs that were looking at Amex bills and finding 50 rogue Amazon accounts. And so this idea of shadow IT meant that an employee could install software without the approval of the organization. But I think that we're about to find a much bigger problem, which is shadow workforce, where I don't install SaaS as a tool so humans can work. I install SaaS as a console so agents can work. And so I'm not installing a CRM. I'm installing a direct inside sales department. And so that's not a case of shadow IT. That's shadow workforce. That's not the CIO's problem. That's the head of HR's problem. And I think that this is something we have not properly thought about that is going to be fucking up every major company in the next 6 months, is this idea of any employee can install a shadow workforce, and they don't even know whether they should give that guy a bonus or fire him. So that's what I'm currently thinking about, Ruve.
You hit it dead on. And when you look at how I work with the biggest companies, I'm a lucky guy. And what's happening is I've reduced the friction for them to hire me. All they need to do is go into my little booking site, put in their corporate card, and they're like, "Hey, Rube, how do I create the swarm today?" And I've got this idea that my company said it's going to take 2 years and $5 million. What can you do? And literally within the hour, we built it completely. And I did this I did a presentation to probably the largest. I won't say who it is. You'll guess if I say what it is, but a very, very, very large company. And they're like, we had this idea, and they said we were quoted $2.5 million yesterday to build this thing, and you just built it for us in 45 minutes. I didn't really build it though. I took what they said, popped it into my little swarm, and said, "Go build me that." And I showed them some PowerPoints and gave them the code at the end of the call. And that's like a leading sort of indicator of probably where we're going to be. And imagine when everyone else catches up, what the world looks like.
Yeah,
it's crazy.
Yeah. So weird.
I had this same conversation. I was at a function in San Francisco last week, Alistair, and this is exactly, we were talking about puppet masters and puppets, and I couldn't agree with you more that it's certainly a frontier. And I think the other thing is we talk about who's impacted. Like, you think about how much of our work is outsourced to a third world country. Like, as much as people talk about, like the fear of what's happening, I'm like, well, it's already a mess. Like, it's already smoke and mirrors and gamification of a process. I think it's going to be rough, but I anticipate a better future because we're just doing better things.
This is the conversation I've been having with the government. So again, with the ADHD thing, I also run the world's largest conference on public sector modernization and digital government. And those guys, most of them are very much like, I don't know what I'm going to do. I don't know what I'm going to do. But when you can do $8,000 of legal work for $3 of tokens, the taxpayer is not going to put up with a 3 order of magnitude more expensive human. And so the way I see this is right now, if you are trying to do claims benefits for our most vulnerable humans, that stuff's hard. If we can get 99% of those claims benefits to be done for 1/100th of the costs, then as a human, I am 100% fine with the 1% being a social worker, government employee who goes and does a safety check on them, health check, maybe brings them some food. Like, that's the world I want to live in. Do think, like, right now, I firmly believe that a fundamental human right in the digital age should be that nobody should know more about you than you do. That just seems like a very good tenet. But if we were to enforce that, the government already knows tons of things about you. It just doesn't make it easy for you to look at them. So imagine that now, because the government has AI running the bureaucratic stuff, that it can focus on the good things, like a cradle to grave timeline where you can see all your tax history, your vaccinations, your medical history, whatever else, right? We can now build these amazing things. The real risk is that the reason fascists lose is bureaucracy is hard. And if we make a system that makes bureaucracy unthinkably easy, it may be impossible to install a fascist state that we cannot counter as free-thinking citizens. So there's this bet we're making that we can get well-aligned AI in the hands of well-aligned humans and improve quality of living and give people dignified jobs and more meaningful human interactions faster than we can give a few people the ability to surveil us so much that no form of dissent is possible. That's the
Alistair,
reason I don't sleep.
you're spot on.
We have to come back to that. We've two other guests we want to try and sneak in before the top of the hour, but then we'll have an open session as well after the 1 o'clock. Thank you, Alistair. There's bang on some incredible insights and thinking and conversations.
And before we leave, where can folks follow Alistair? Maybe get his book. I'm sure it's on Amazon. Alistair, this is your chance for a little bit of
Oh, it's way better if you go to justevilenough.com and buy it directly from us, because then I have your email address and I can send you stuff. Yeah.
Perfect. All right. And Alistair, thank you again for coming on. And if you want to stick around, we have an after show where we usually go into crazy philosophy.
Yeah, for sure. I'll stick around.
All right. I'd highly suggest getting Alistair's book. Lean Analytics is actually one of my favorite. Got a signed copy. Thank you for that, by the way. From like 10 years ago. You and Ben were amazing. If you don't know Ben as well, he does some amazing work with his startup work. All right.
Super. Chris
Moving
Poulter.
on to the next. All right, Chris.
Yeah. Hey, Chris from the UK group. How you doing?
Hello. Very good, very good. I was getting a bit confused there because I kept turning around behind me. I'm like, yeah, it is that book, isn't it? So yeah, that's very cool. Got a copy of the book on my shelf. That was very unexpected. Thanks, Alistair. Cool. So yeah, a bit of a tricky one to follow up with. I'll be very brief. And like I say, change of tone really. I've been working on production code bases with agentic tools for at least 12 months now. And one of the toughest things I found was how do you actually make sure that what actually makes it into production is not going to break stuff. That kind of generally helps, right? So the first thing we tried to do really was go, okay, how can you treat an agent like a junior engineer, right? A very talented one, but just someone who needs your guidance here and there. So the first thought was, well, let them go away and do the research and then come back and be like, okay, here's what I want to do. Here's a detailed plan. And you can look at it and go, yeah, that's all great. We don't want you to lose that library there because actually we're using a different library somewhere else in the code base. So can you reuse that stuff, please? And where that brought us to was actually creating these YAML task files. Yeah, and all this really is like a runbook. It's a very detailed way of describing exactly what's going to happen when the agent starts coding. So it's very much aligned with that kind of think left thinking from the DevOps world, where it's like, hey, if we can make all our engineering decisions up front, then we can work with absolute confidence that whatever it builds is going to be in line with the rest of the production base. Right, so this was my starting point. We've all started using Claude Code probably over the last few months, that kind of thing. And a couple of things triggered a step change in this because first of all, I watched a podcast, I think it was the Every guys, and they were talking about how they use GitHub projects, and that sounded really cool. I was like, okay, I need to check that out. And then I was also looking at GitHub Actions and how you can run Claude Code within GitHub Actions. So it started to kind of trigger some thoughts for me, like, hang on, how could you actually kind of automate a system around this where you could start using the GitHub issues and projects to actually manage the workflow of your work? Previously, I'd had it in the code base, and that's a bit clunky when you've got teams working on stuff. And it turns out it's actually really easy to do because Claude Code is very well specified. It can work very easily with GitHub. GitHub issues, GitHub projects, everything else. So you can tell it to create issues very easily. This is a custom command we created. And all it needs to do is kind of somewhere down here, I think it has, yeah, it just executes on the command line, GH and whatever things it needs. So we can then create issues from within Claude Code. Then we just think about kind of what workflow do we want where we maximize the agentic ability so that we don't do the legwork, but we still have these approval steps, right? And so for me, it kind of came down to 2 steps, which can be very brief when the agents are good, like Claude Code, but nonetheless quite important. So first of all, when we create an issue, then we can use automations to trigger Claude Code, and we can execute our kind of research task, which, well, if it's a bug, then we'll want to recreate the bug. We'll want to see if there's adjacent bugs around it, what happens if we change the parameters a bit, etc. If it's a feature, then we might want to understand how we're implementing similar features, etc. Right? But the first stage after that then is doing the research, coming back with a report and go, right, here's all the technical information that you need to know. Here's the approach that we're likely to take with it. And that gives you a really early stage to say, yes, that's great, or actually, we should be going in a slightly different direction there. Yeah. Once you've then approved that, then again, Claude Code can do its thing, and it can go and write one of these YAML tasks, which we were looking at. Yeah. Now, this is really cool for a few reasons. First of all, we are forcing it to load the context that we want. Claude Code's actually very good at context, but Cursor wasn't. So this is much more important with Cursor. But just like with a junior engineer, if they're working on a particular part of the code base, it might not be obvious that it actually impacts stuff in other places that they haven't seen. Therefore, what we can do from the outset is go, okay, you have to load these files into context so that you understand the broader implications of what you're doing here. Then we can take it through the steps that we want and be very specific about the files and the functions being edited. And finally, we can enforce our checks. So we can say, hey, you have to run these tests. They have to pass. If not, you need to loop through until they work or until you kind of give up. So again, that gives us just a nice runbook task, which we can have a look at. 9 times out of 10, we can approve it. Occasionally, we'll need to kind of make some tweaks. But from there, we can be pretty much guaranteed that what we produce in the PR is going to be good to merge, because actually there's very little chance that it's gone off, done something that we didn't want. And ultimately, my aim is always that if I'd sat there and written the code by hand, that the end result from the agent is exactly the same as what I've written. And so far, this is the best way I've found of doing it.
Interesting, Chris. I like your approach. The one thing you might want to consider as part, I also integrate projects. I've been doing that for a while. You might want to consider using Claude in the form of the swarm approach with the make sure you reference batch tool and use the work tree option within GitHub, and you can create multiple trees that can each part of the swarm can work on separate but concurrently, so it doesn't necessarily conflict with one another, which is really, and then at the end of the swarm process, it brings it all back together. Your structure would be well suited to that, but nice work. Looks really good. All right, we don't have a lot of time. I apologize, but we can come back to Chris if you want to stick around at the top of the hour, and we can dive into some other things. Just as an update, I think I've created about 60,000 lines of code so far for that Poly Market addition to the trading platform. Yeah. So I'm hoping by the end of the session we'll have a fully functioning Poly Market component as well. So for whomever mentioned that, thank you. That's a cool addition, by the way. So I'm excited to see how that works. Who's up next?
We have Everett. Hey, welcome back, Everett. Did I get that right? Master's in Aerospace Engineering?
Yeah. Thank you. And it is great to be back. I really appreciate Alistair's take earlier. I think it's easy to try to have a lot of positive spins on a lot of the technical innovations, particularly if you're technically minded. I had something working, and then I made a few edits trying to get the because I've had some success in the past of vibe coding a debugging update within like 30 minutes of a presentation before, because I feel like that's where we're always at. But I want to give a quick update on the project that I presented on last week, and then also just kind of share a couple other things that are going on my end.
Breakage is like our specialty. If the demo doesn't break halfway through, you're not doing it right.
Yeah. So for those of you that don't know, 2 weeks ago, I presented a project that I've been working on for a long time called Archetype. And Archetype is a simulation engine which is intended to handle all the state management so that LLMs can then go and generate simulation scripts. And the goal there being that once I get like a Gemini CLI or like a Claude Code integrated with this type of a system, that then those agents can then like generate simulations themselves recursively, potentially perform some sort of Monte Carlo tree search to effectively explore different realities. And then they're only concerned with, like on the token side and usage side, declaratively describing like what simulation they want to have. And so prior to this, I had shown everybody just the toy examples, which, in traditional physics, I come from the aerospace background, worked at Boeing Phantom Works for a couple of years straight out of college, and then moved into the big data space and big tech. So that's the area that I live in. And so, I talked about some of the technologies that I use and everything, but effectively we've got this naive simulation here that just updates a position of entities after each simulation step. And then eventually you'll just like see lines, that move from point A to point B each step. But that's not really interesting, and it's particularly not interesting to the agentics community. So the thing that I've been working on is integrating the ECS processors with an OpenAI client. And this gets into like key bottlenecks in like batch inference. Trying to test different concurrency models. As of right now, Archetype supports running multiple worlds in parallel. And so there's a couple add-on modules that are going to take that from just being able to run this locally on your laptop to being able to run this on Array. And then the goal there is this is effectively, as much compute as you can throw at this, you can generate more and more worlds, more and more simulations, more and more entities. And this automates a lot of the data engineering and like state management for these large scale simulations. So the thing that's not working right now is this experiment that I'd like to run. And I think it captures the overall orchestration that I think maybe a lot of us use when we're chatting with OpenAI or any of these LLMs, where we like to explore different perspectives, just evaluate a bunch of different options. And this is kind of your classic ensembling use case. I've got a worker and a judge, and then the worker can go and generate a bunch of answers, and then the judge will go and evaluate those answers. And so then the thing that I was going to present to you guys today was that this nested semaphore-based concurrency model for this processor is not optimal. And so I was going to actually use my own simulation to come up with new concurrency processing mechanisms. You're a super intelligent AI, you'll be asked to provide a code snippet that implements the prompt. The prompt is, hey, I've got this processor, it's really freaking slow, make it faster, and then it's instrumented with that. So the simulation scripting semantics of this are actually still a little bit in flux, but the long-term goal is that we're operating with millions of entities in parallel, and that they can work, and the entire backend is built for with big data like open table technologies. So reading and writing from storage is cheap and has like minimal overhead. So zero copy reads and writes if you're a big data nerd like I am.
All right. So we're almost out of time in the first hour, but it's just quickly, what are the practical applications? Like where would I use this?
Yeah, so for Archetype, this is effectively going to give your AI agents superpowers. You have some sort of, if you've got a system like Claude Code or Claude Flow, instead of the agents being concerned with like going and generating all of these simulations and like running it itself, it is effectively simply operating as an orchestrator. What this ends up looking like, particularly for code generation, is that you can begin to declaratively define your evaluations, your benchmarks, your code generation, and it means that you don't have to compromise on or stick to just one answer. You're going to go and explore the entire solution space. So it's great for exploring open-ended questions, scientific discovery, financial modeling, anything that you want to run at scale.
Cool. So is there an MCP interface for it? Can I just add it to Cloud Code?
That would be it's in the roadmap. It's in the roadmap.
You'll have it in what, 10 minutes? MCPs are so easy to create, right?
Yeah, that's
swarm it up. I expect to see it by the end of the hour.
Okay. Okay.
I'm not even kidding. MCPs are super easy. And anything that can have an interface, like whether it's a CLI, should have an MCP interface. And the ability for everything that I'm building to interact with everything that I previously built through an MCP makes it all kind of like a Lego building block sort of approach, right? So I like what you're doing. I'm excited to see. So it's like a world model system simulation. It's pretty cool.
Yeah.
All right, this is the open part of the show, guys. And Everett, really appreciate you taking the time. Before we go, where can people follow you, learn about what you're doing, social, company, whatever?
Yeah, you can follow me on Twitter or on LinkedIn. Definitely, those are the places where I'm posting the most content. I've also got a YouTube channel, and I'm adding more videos, updating folks on my progress here.
Awesome. And share if anyone wants to connect. Share your LinkedIn in the text area and we can all connect. And you notice that a lot of us have our little infinity logos because we're of the foundation, the Agentics Foundation, which we're trying to spread globally. We've got 60 cities where we have ambassadors and things happening all over the globe. So hopefully if you can't meet online, you can meet in person or vice versa. But this is this is the open part of the show, meaning that's the open mic. So if anyone has something you want to share, say, whatever, this is your chance. We got Dennis. Take it away.
Hey, first of all, I need to leave in a second, going for dinner with the family. But I just want to follow some of the stuff that Alistair was talking about. And I have to say that I also share a little bit of optimism. I think we can make this work for the best. I do think that Europe needs to play a big part, in Canada, actually, because I think we are a lot more aligned where we need to go. The thing I want just to comment is that I feel if you follow this sort of swarm, and in a way, Ruben is doing some ridiculous, crazy stuff, right? But if you follow this idea that what we're going to be doing is empowering a lot more the smaller entity, I think we will see a lot more distribution, right, of that power and not that centralized top-down model. And one of the things that I remember saying that people thought I was absolutely crazy when I was in the corporate world is I used to say that every dev team, every team in the building, every part of the organization needs to have a developer, an engineering function, right? By the way, I used to do in security. In my teams, I used to build engineering teams inside cybersecurity. And I think what we're going to see is that I think, yes, there's a place for the crazy stuff that Ruben, you're doing, but I think in a more realistic world, we're going to start seeing a lot of development engineering and experience being hired by every single function in the business, because every function in the business, and yes, some will be made redundant, but I think others will actually be able to execute a lot better. So I think the dev world is going to move to that sort of packaging and productizing, and everything in my world is a worldly map, where you basically have a lot of Genesis stuff, and then you need to bring the devs or the engineers and the architects to actually glue things together and to make it work, so the other guy that was presenting that making something work reliable at enterprise level is very difficult. So I think there's a huge opportunity to actually bring a lot of engineering excellence and a lot of practices that in the past never scaled into a lot of these other business functions that it didn't exist before.
I get it. And just, I get a lot of pushback on the crazy things I build. I'm building these things not because they're necessarily even practical. I'm building them just because I can. Right. And if there's no practical application, that's almost secondary for me. You know, for all the pushback. I mean, oh, why would why would anyone actually want to use that thing? Well, I don't know. Doesn't matter, even matter really. But appreciate the insights. Oh wait, and we got Chris, our friendly neighborhood vibe coder. What crazy things are you building today?
Well, I was messing around with that cognitive triangulation architecture with the agents, with having them analyze different viewpoints, and that's been really cool. But recently, I've put out Fairmind, and you can go to fairmind.ai and you can get access to it. It's essentially an agentic dev team. It follows your Spark architecture roof, and the dev team basically walks through the whole process, and it has a shared memory system. And not only does it just build things from scratch, but it works with you, it moves with you. Like when you want to make adjustments or improvements to the program, it manages the whole thing, and it's super cool. And if you'd like to try it out, it works with, Claude Max. You can use Claude Flow with it. It's model agnostic. So if you want to check that out, you can go to fairmind.ai and check that out as well.
Can you put the link in the channel?
Yeah, absolutely.
Oh, there it is. Cool.
I love the stuff you're cooking up, Chris. You've always got something that's making me ponder what I should build. These events, like the reason I create so much stuff on Monday and is because of this, right? Every Friday I get way too many ideas, and then the swarm builds it all weekend, and I've got something to show. And I think Chris is a big part of that. Again, we're open here to any discussions. We've got Alistair, who's one of the best thinkers I think I've ever met on. So, Alistair, what are you thinking about our show, by the way? Are we crazy or what?
There's an old adage that most technologies start out as toys. When the car was first invented, it was for rich dilettantes. And once some little kid hand cranked the front of it, he had to walk in front of you with a flag. It was a toy. No one ever thought it was going to change the world. If you want to get inside the OODA loop of any technology, you need to play with it before its purpose is obvious. Not just because that gives you fluency in it, but because you find these weird use cases. The problems of today can never be solved with the systems that created them. And so I think I think play is underrated. And Ruve, I think I've always known you to be the guy who likes to play. I think you may want to talk to someone about it, because you kind of have a compulsion, man. Like you may want to, you're compelled to play with technology, whether that's like cloud containers or the latest agents. But I think what's interesting is tolerance for play at technology inflection points is what is necessary. And just the fact that you're building things with your kids too. So I think it's important just to remember, cars started out as toys for the rich, and the sooner we play with things, the sooner we figure out what they're for.
But Alistair, you mentioned the OODA loop, right? So you know about worldly maps, right?
Yeah, Simon and I are buddies. Although when he does the worldly maps in the room, I'm like, that's obvious, and then he leaves, and I'm like, what? I can never sustain it. It's like a reality distortion field. But yes, I like Simon's way of looking at the world.
So Ruben, and I think I was here, now I classify my this, I think he's the typical explorer, right? So you try things out, you go out there, you create things, you fail, and success is almost measured not by it works all the time, but did you move the needle? And then you feed on each other, right? And that's key part of it. That's the key part of evolution. And then you need the villagers who take that and start to sort of make it work repeatable. So it's sort of like usable by others, and then eventually becomes a commodity. And that's when you got the town planners.
Yeah.
Right.
I just like to experiment and push the boundaries of where and what's possible, just because. I don't, is there a reason beyond just creating because you can? And that's a good enough reason, I think, for most of the things I create. And keep in mind, I'm doing that in the midst of my actual job as a consultant. So you guys don't even see all the crazy stuff I'm building for like people who actually pay me. You're just seeing the stuff I'm doing in adjacent to that. Who else we got here?
I'd just like to just add an aspect there. When Alistair's talking about, the myriad of solutions, I can't remember the name of the paradox. When the price of a commodity comes down, its usage picks up, right?
Jevons paradox.
Jevons paradox, right? Okay. So as code begins to move towards 0+ energy, gets faster, gets cheaper. I know the sort of, I understand it as the uncovering or removing of market efficiencies as a type of triage, where more and more firms can more quickly become aware of more things, and even on the procurement side, supply lines and all those kinds of things.
Well,
And it
but
moves down market.
there's a weird tension there. If you live in a world where everybody uses Salesforce, it's imperfect, but Salesforce is doing its debugging and maintenance once. If you move to a world where now everyone has their own CRM that they built themselves, now everybody's doing maintenance on all their own stuff. So you no longer get the economies of scale. And so there's always this tipping point about economies of scale versus the efficiency, right? Is it more efficient to run the stuff to manage those? So there's always the one lesson that I keep coming back to in looking at like civilization, like at all of civilization, is that civilization is a tension between the individual and the collective. There are times when it makes sense for the rogue coder to go off and build their own thing, for the thief to steal something, for the individual to speak out against the tyrant. And then there are times when it makes sense for us to get together and buy an MRI or build a road or, fix the barn or defend ourselves. And if you have too much collectivism, then you don't have innovation and you have the possibility for stagnation. If you have too much individualism, then you don't get the efficiencies that come with economies of scale. And all societies and all political parties and even all relationships are an attempt to find, and it's always changing, the optimal balance between individualism and collectivism. And so you're going to see the rise of like incredibly personal individual, I've got my own AI stack, but then I'm burning so much extra energy trying to maintain that stack that maybe I'm okay with using one that's not exactly tailored to me. I think there's going to be a negotiation in society between those two things. For the Jevons paradox problem, it doesn't happen for every market. Jevons was specifically studying the use of coal in England in an 1890 paper called The Coal Question, because the British were trying to figure out James Watt's engine was 4 times as efficient as Newcomen's atmospheric engine. And the British were like, okay, how much time do we have left? And the reality was that cheaper stuff makes people use it more. So I'll shut up after this one point. There's a guy I love to think about named Herbert Simon. He was a Nobel laureate, invented the economic term satisficing, which is sort of sufficient optimization. And Simon is the guy who coined the term the attention economy. Back in the 70s, everyone was talking about the information economy. He said economies are driven by what's scarce. We have to thank you very much. You can listen to me for hours if you're interested. I do, by the way, I do have a Substack. I'll paste a link to it in here because I write stuff on it from time to time. So Herbert Simon said, look, the reality is that economies are driven by what's scarce, and we have to ask ourselves, what does this thing consume? So information consumes our attention. Therefore, we live in the attention economy. And so the best lens I've found for looking at AI is to say, what does this thing consume? Because that's what will become scarce. And that's a very good model. I like that better than Jevons paradox.
Yeah, those are really good points. One thing, the economy of scale is interesting. Now, let's assume this evolves quite a bit further than we are today. And we're on the cusp of what do we want to call it, AGI, ASI. I have the ability to create anything that pops in my mind by just, thinking. When we get to a point where there's, their fidelity means that there's no exploitation, the bugs are limited, and I can create things that are as capable as any commercial grade software, instantly, which we're probably not that far from, maybe a few years away, probably at the most. What does that say to economies of scale? I don't need the 10,000 Google developers anymore, do I? Right? And that's their competitive advantage. They've got the ability to spend 2 billion or 20 billion on their AI infrastructure. Yet I can compete with any of the largest companies using the cheapest low-end stuff and outbuild them and it's pretty clearly, maybe it's not production ready. It doesn't have to be. It's ready enough that you can take Claude Code, point it at it, and say, fix it up for me or change it. Right? It just changes the structure a little bit, I think.
Yeah, Rolf, but what prevents Google like hiring like 10,000 of you and giving them like $1 billion of like token costs, like, and just scaling
Well,
it
here,
up?
look, let's take a quick look at the poly market, just as a 10,000 versions of me approach. So while we were talking, it built the poly market component, and I just ran SCC on it, the our favorite code analysis tool. And let's just go down to the bottom here. And in the last, it was basically an hour, it's generated 24,000 lines of code, 17,000 of which were Python. It estimates, this is totally a BS number, and this is to Alistair's point about sort of the value, and the more, and Rob's point about the more you create, the less it's worth possibly. But anyway, it's saying it's worth $500,000, 11 months of effort, and 4.5 developers. And literally, you guys gave me an idea to build it, and it's not quite done, I don't think. Yeah, it's still doing the last sort of testing phase, but it's pretty much there. I'll have this ready to go here probably in the next 20 minutes. And it was just, this thing alone, would have been a year's worth of work for a team of 5 people a month and a half ago. Right? That's how fast things are going. We're in this kind of exponential curve of capability, and it's really hard to see when you're in it, but it's pretty clearly we're in some kind of massive transformation in our ability to build and create things. All right, I'm gonna stop running.
Alistair said earlier about that it's HR's problem, and it made me think about the future of work. And I wanted a question for Alistair, and trying to figure out if I'm the widget man and I make 5 widgets, and I figure out how to make 10 widgets without the same amount of work, wouldn't the criticality to the org be to educate the organization on the value for that individual to the organization, rather than looking at it from a standpoint of that person is maybe cheating his job, cheating his work, and just re-educating the org? Because it seems very much similar to the whole DevOps process. And people,
if I was CEO now, I'd be like, look, anybody who can figure out how to efficiently replace their current job with an AI will get 20% of their current salary for the next 2 years. They don't have to do that work anymore. But if it breaks, it's your job to fix it. And so then you can go do another thing. Like that would be the best way to incentivize, because then I can go replace 10 jobs and make myself an annuity, right? But I don't see companies trying to incentivize them. They're like, oh, how dare you use that tool or whatever. There's a whole other way of thinking about it, which is like, I'm going to give you an annuity, a cut of the profits for some foreseeable window for replacing that job.
I might be a little biased because I'm the agentic engineer. I'm probably one of a small group of people who even call themselves that globally. But out of my 100 or so customers, I think 17 are Fortune 500 companies. These are companies that have probably north of 20 billion in revenue, and of those, which is a small sampling of a much larger group, mind you, they're all looking at ways to do exactly what Alistair you just said. They're saying, how can we sort of augment our existing people, and how can we sort of, I don't want to use the word replace, but I'm going to talk plainly for a moment. How can we replace a certain portion of our workforce with autonomous things that do these things better, faster, and cheaper? And that part is scary to me. It's like, I don't want to be the guy coming in and replacing 15,000 people in an afternoon, which I kind of can. What happens to those 15,000 people, right?
The thing that's missing in the conversations that I'm hearing is what Alistair just said, is the incentive to say, how can your job is 5 widgets. If you can figure out a way to make 10 and with 1 hour versus 40 hours, then you can have the same money, or you can go sit on the beach. That part is not in the conversation that I'm hearing. What I'm hearing is, how can we replace the person with AI, what you said, Ruth. So
I'm sure there are a number of people here who are further along in their careers than I am, and I'm curious, if you get more work, if you finish your work for the day and there's still time left, what is the reward? For me, it's been more work.
Yeah.
Well, I want to offer a different perspective. So instead of thinking about jobs being replaced, think about the problems you would solve if you had the time.
And
So
that makes my point exactly, Sandy.
Yeah.
yeah.
And Sandy, I think
The
we're
reward
looking.
is more work.
Right. I think we are really looking in the territory of intrinsic motivation being more than a theory. It's become a reality for me and for many here, I think. Like, we are not doing this for money, right? It is basically helping us create and solve problems, and money just follows effectively. Yeah, that's how I look at it. But I think this point about, like, how do you organizations reward people for creating this and create a sustainable kind of annuity? That's a great thought, actually.
Actually, yeah, I was just thinking about this, and this kind of gets into sort of global issues, but like, we have all these things happening. We have a lot of weather changes, we have microplastics in the air and the water and all these different things. And with these capabilities, you can actually start, the conversations always are, how do we monetize this, right? And getting plastics out of the water, it's not very lucrative. But with these capabilities, you can actually do this now. And once we apply these capabilities to robotics, then we can do so much more. And I think what we're seeing is this sort of dawning of this capability where we can actually, like, I always feel like all innovation is driven by the ability to see. And this technology gives us the capability to build tools to see better and to understand better. And then once we can do that, we can actually build things that we can't even imagine. And I don't know, I think that's kind of so exciting. And also big fan, Rue, this is amazing. So
Yeah, I
Well,
think that's awesome. I think that I'm detecting a theme. I think we're all saying very similar things in a different way, which is that these AI tools are allowing us not to be just incrementally better software engineers or product managers or whatever, but orders of magnitude better, because they're like all the things that we thought would be nice to do, but way too difficult, whether it be fuzzy searching, whether it be massive data and analytics, suddenly it's within our grasp. And that's pretty exciting.
Yeah, Mark, to
But
your
even
point.
think about, yeah, go ahead.
Well, I was just going to say, to Mark's point, there was a young lady we just met on the meeting earlier this week. She has a son who has I don't want to say a business or whatever, but has a difficult disease. And now with the ability to have access to these tools, to where, you're looking at where one, you would used to be able to be a deep developer to make a web page. Now access to these tools, she is able to go out and create something that could actually save not only her son's lives, but others' lives. So it's really, really exciting. And apologize, Sandy. So yeah.
No problem. So again, like, when I start thinking about it, I mean, like, why do we have governments? Why do we have, like, we these type of tools give individuals enough capabilities that some of the things that we typically have relied on for local, public policy and stuff, maybe that goes away. I think this is much bigger than just being able to code faster.
So,
but we have
Sandy,
things.
if I can point one thing, has anybody here heard of the term Moloch? Moloch. It comes from an Allen Ginsberg poem. So Moloch is the god of perverse outcomes. Humans have coordination problems. No country wants an army, but we all have armies because someone else might have an army. Things like tragedy of the commons, right? In a world without perverse outcomes, where there is perfect knowledge of all participants, game theory says you can have that idealized world. We don't need governments. Governments, and before them, and I'm an atheist, pretty proudly so I apologize if offending anyone, but governments, and before them religions, were excellent ways to get people to behave without surveillance. When law enforcement is legitimate, we pay a ticket because we believe that it is for the greater good, for people not to speed or whatever, right? So governments exist to fight Moloch, and I'm going to find it. There's Liv Bowery, one of my favorite thinkers, did an amazing explanation of what is Moloch. It's the dangerous part of competition. It's necessary that we are all constantly optimizing for stuff, because otherwise we grow complacent. But as soon as I'm trying to get the better of you, the system that we're in benefits, but you and I don't necessarily benefit. I win, you lose because I cheated. And then you get tragedy of the commons problems. The pond gets overfished or whatever. And so I think we need to look at government as a coordination problem. The real risk here is, do we want to abdicate coordination to a system that thinks it knows best? Because then the coordination for the greater good is defined by, you know, what Peter Thiel thinks greater good is or whatever. And that's obviously
I
the
agree.
issue.
So what about, do I train it myself? You know, like I think there is a danger if we're, you know, I don't want to turn over my morality code to OpenAI, Google, or some else. Like I don't want them telling me what's offensive, not offensive. But, and you know, who knows what's ahead of us, but could I then, so do I build my own group of puppets that are based on my view of the world and my morals and my ethics and how I think and what's important to me? That's where my brain went, Alistair.
I
But
don't think we can have a society, functioning society, as in like pure, not pure anarchy, unless we do two things. One is we're going to need to be able to distinguish generative speech from real speech. So there's going to have to be essentially the equivalent of chain of evidence for facts because so this picture was taken and there's a person making a claim whose identity I can verify, and mathematically it has not been tampered with. So chain of evidence, like in law enforcement, is going to be necessary for all forms of information. That's the first thing. And then the second thing is there will have to be regulation on what is allowed, because any runaway technology like biotech, which can self-perpetuate, has always been regulated.
yes,
Otherwise, it will just self-perpetuate. And so I think we're going to see strong regulation on self-perpetuation. I don't know how we will enforce that, but I think we're going to have to see it. And unfortunately, that may be fairly draconian. Like it may even be to the point of there's a monitor on every processor sold that can do this stuff. Like I don't know what it is, but I do think that society will not function if there isn't chain of evidence, probably some kind of distributed ledger, and some kind of very strong regulation. Now, I want to leave you with one scary thought, which is that when a crime is easy to commit and has widespread consequences, the punishment is always incredibly strong. Horse thievery in the Old West was punishable by death because it was super easy to take someone's horse, but you left the person to die in the desert, right? And so stealing a horse was punishable by death because they had to make the punishment so draconian people would not take it. When people used to shave coins, if you're familiar with coins, they used not to have these little ridges on the side, right? And Isaac Newton figured out how to ridge them. People would shave a little bit of gold off, not enough to be noticed, and the currency of the realm would diminish. So coin shaving was punishable by death because it was easy to do and hard to prosecute. I suspect we are going to see certain things that are easy to do and hard to prosecute around AI having incredibly draconian punishments, outlandishly unbalanced asymmetric punishments because of that potential.
But how? All right, guys, we're almost out of time here. I gotta jump, but this has been this is one of my favorite episodes yet, I think, and I really appreciate Alistair and Chris and Everett and Rob and everyone, Vlad, everyone that's Sandy. This community is amazing, and I really appreciate everything that you guys bring to this. Just a quick note, you know, we've got the Agentics Foundation, and the crew always tells me I need to promote it more. We are a bunch of volunteers that come together for a shared passion for making agentic engineering a thing. It's becoming a thing. We see other companies, big and small, adopting the terminology all of a sudden. So we're in the midst of that. We've got a number of events coming up. I think Ocean, you mentioned I'm not sure if you're still on the call or not, but him and the crew, Willie V and the crew in New York are going to be doing it on the 10th for anyone that's in New York. I think we got Indianapolis coming up as well for those in the middle there who want to help out. And if you're interested in doing an Agentics meetup, we're happy to help. basically putting this on Luma, and you get 100 people showing up these days. So really easy to do. We've got materials for you. We can get you a t-shirt. We got some shirts coming. Rob, have I forgotten anything? Probably. But
yeah, just if in your city you want to start one up, go to agenix.org/ambassador, fill out that form. That kicks off the process, and then
we got a new website coming. Brad's been working. Brad and the crew.
Coming.
Yeah, so we're gonna be fixing that all up. I know you those who are paying. What am I getting? I don't know. You're helping us keep this thing the lights on right now. But we're going to be better organized. It's again, none of us are being paid to do this. We're all volunteers.
And we could actually use a volunteer coordinator.
Hey, Rob, very quick question. Do you have somebody in Boston? Because last week I discovered there is an alternative group. It was like 200 people meeting, and they kind of doing very similar with what we're doing. But
there can be only one.
Yeah,
no,
but do you have any ambassador in Boston, like, or should I?
Not yet.
Yes.
Not yet. No.
Okay.
So I know that we have some folks there, so that'd be great.
Yeah, we have a number of we have lots of people there. We just need what we need is someone that's willing to sort of take on the responsibility of saying, let's do this thing next Tuesday. Okay. You know, right? So you're in Boston, Vlad?
Yeah, I'm in Boston, yeah, and I just discovered the group, like it was very similar. And
well,
actually they charged $20 like to attend, and there was 200 people.
I don't want to charge. I don't know, guys. I, mean, I don't want to charge.
They just charge. They get better food, like in a beer. So that's
well, right. maybe we get a sponsor to pay for the pizza or something. But I don't know about charging. That's a different thing that I don't want to go down that road. But if you're willing to volunteer to help organize in Boston, we should totally do it. There's so much going on there.
Yeah.
I can
All
help.
right. Nope.
If you're in Chicago, ping me. And maybe we should be setting up coordination over there. I'm not sure if there's somebody else already that's out there.
Not Chicago, Everett. Would that be great?
Yeah. Let's talk, Robert.
All right, guys, I gotta jump. I'm gonna be late. All right, thanks for everyone. This has been an amazing episode. Alistair, I love your insights. You're such an interesting guy, and really appreciate you taking.
Thanks for having me. I really enjoyed this. This is awesome.
All right.
Thanks, Al.
Nice to meet you. Next week, 4th of July. There's no AI Hackerspace next week. So I might do Thursday, the live coding session, because I'm probably going to be coding anyway, but there won't be a Hackerspace. And so anyone that's interested in having something to present or you want to show, get in touch with Rob and we'll get you on and get you a segment. And you can show off what you're building. All right. Till next time. Thanks, everyone.
Thank you.
Okay.